Welcome back, pre-calc. We are gonna finish up and we're gonna put it all together. That's what we're doing. So what they actually did is they actually started by factoring this thing out for you already. Notice the negative leading coefficient here. Negative leading coefficient. And that's gonna put a little I guess a downside in our method of doing this. But as they've already factored this for you, you can double check that they factored this correctly. The non-canceling factor in the denominator, I always start with a canceling factor in the numerator and denominator. That makes more sense to me, because then if you cancel them, and we're looking at identify the factor, that's x plus 1. You set it equal to 0, that's your clue that you have x equals negative 1. And as you look at that problem, that's your whole at negative 1, 5. Well, how did they figure out 5? Well, you plug negative 1 in for the simplified version x's. So we're looking at positive 2 plus 3 would be 5. And then negative 1 plus 2 is 1. 5 divided by 1 is 5. I would do that first. That's my opinion. You don't have to do it my way, but I would do that before the non-canceling in the denominator is x plus 2, which would be your clue that x equals negative 2, and when it's non-canceling in the denominator, that's your vertical asymptote. By the way, your graph is down here. I don't know if you noticed that already. So as we look at the non-canceling in the numerator, we're looking at that negative 2x plus 3. When you set that equal to 0 and solve, I would subtract 3 over and divide by negative 2. Well, negative over negative gives me 3 over 2. As you look in your graph, that is your x-intercept. So the non-canceling in the numerator is your clue for an x-intercept. I guess I should have wrote this down as I was doing this. Non-canceling factor in the denominator is your vertical asymptote. Let's see, I did this in orange. This is the canceling factor is your whole. And then your last one is the quotient of the constant terms, which I started to explain at the end of the last, is your clue for the y-intercept. I don't really like to teach it that way, even though that's how this is written. The reason why this works is because x equals 0. Well, 0 plus 0, you get 3. 0 plus 0 plus 2, that's your y-intercept. As I misspell stuff, y-intercept is 1.5, 3 halves. So what are we missing? Let's look at this. We're missing the where this thing is located. Okay, as all of our points are over here. We found the vertical asymptote, but we are definitely missing this thing as well, the horizontal asymptote. How do we figure out where that horizontal asymptote is? Well, let's answer some of these questions just to finish and have good notes. So when the equation has a factor in the denominator that does not cancel, then it has a vertical asymptote when you set that equal to 0. When the equation has a factor in the numerator that does not cancel out, that has an x-intercept. When it does factor out, numerator and denominator, that gives us a whole. We've talked quite extensively about this. And in standard form, that point 0c, where c is the quotient of the constant terms, is giving us the y-intercept. So if you haven't figured that out by now, there are your key terms, but we're still missing a few things. So how do we determine if we have a horizontal asymptote? Well, as you look at these things, the premise is to look at where the horizontal asymptote is located for both of these. And this person that wrote this actually gets you to look exactly where you're supposed to. Where you look at the degree of the numerator compared to the degree of the denominator. So I'm looking at the highest exponent, in case you forgot what degree was. Highest exponent. That was supposed to be a 1 right there. Well, the degree in the numerator, so let me just put degree in the numerator, kind of like this is function notation, is smaller than the degree in the denominator. What do you notice about the horizontal asymptote? Well, for both of these, they have the line y equals 0. Y equals 0. So as we look at some of these other problems, Well, now our degree, we're looking at the degree in the numerator again. This time, the degree in the numerator is 2 compared to this one being 1. This is 2 with this one being 1. Is greater than the degree in the denominator. Well, this time there's no horizontal asymptote. This is what's called a slant asymptote, which we will look at soon, just not yet. These both have slant asymptotes, but the premise is that they do not have a horizontal asymptote, so no horizontal asymptote. Okay, well, let's move on. As we look at these next two, well, this time the degree in the numerator, 2 and 2, 2 and 2, is actually equal to the degree in the denominator. Well, now our horizontal asymptote, well, this one's at y equals 2, and this one's at y equals -1. Okay, well, I guess I could have wrote it right here. Y equals 2, y equals -1. Well, now this person gets you to look exactly where you need to. Well, what about the leading coefficients? Well, if you look at the leading coefficients, we're looking at 2 and 1. So y equals 2 divided by 1. Hey, that equals the answer. Well, look at this one. Well, let's look at the leading coefficients, -2 and +2. Well, that reduces to -1. Hey, that's the answer. So, without putting too much more thought into this, I actually learned this from a student. They came up with their own rules. So I'm going to teach them to you. I did not come up with this, by the way. They called this Bobo, Botno, eats DC. And it makes absolutely no sense if you ask my opinion. But we're talking about the degrees of, so make sure you write that down. We're looking at the degrees. Look at degrees of top and bottom. Whoops, kind of went off the page there. Whoa, and I went somewhere else. Okay, so what this stands for, if you think of it as top and bottom, they wrote it out as bigger on bottom. So the degree is bigger on bottom than y equals 0. So Bobo, like the Bob part, means bigger on bottom, and this O means y equals 0. So again, it makes no sense to me, but it seems to help students, so we're going to go with this. So if Bobo stands for bigger on bottom, what do you think Botno stands for? Bigger on top. No horizontal asymptote. And then the last, if neither of these made any sense, but maybe that helps you remember, bigger degree is bigger on bottom, y equals 0. Bigger on top, again looking at the degrees, there's no horizontal asymptote. Then what eats stands for is exponents are the same. Eats. Then you divide your leading coefficients. I've joked around with that student that came up with eats DC. I said, why didn't you make it eats DLC? And I don't know. It doesn't make any sense to me, but that is exactly what we're looking at. So if you go back in your notes a few pages and you looked at where do we have a horizontal asymptote at y equals 0 if the degree is bigger on bottom. Where do we have no horizontal asymptote? That's when the degree is bigger on top. And when do we divide the leading coefficients is if the exponents are the same. If we have the same degree polynomials, you divide your leading coefficients. Let's get through one more slide. And that is the existence of a slant asymptote. Actually, I'm going to stop right here so that this video is somewhat small and we can finish up slant asymptotes on a new video.